Hello, my name is David Lee, and I'm currently an Adjunct Professor of Economics here at Adelphi University at the Business School. I would suppose I have a rather idiosyncratic background. I have a dual background in both STEM, predominantly in mathematics and physics, as well as in economics and policymaking. Although my undergraduate experience was in STEM, my professional life since then has taken the track of policymaking at the levels of power at the New York State Legislature. I was a legislative director, formerly to Assemblymember Ron Kim of Flushing, Queens, and I spent much of my time writing bills, researching policy, meeting with different stakeholders on a various array of issues ranging from economic development to long-term health care, all with the intention of bettering the lives of ordinary New Yorkers. My current research involves bringing together essentially everything I've done in my life. My first world in STEM, and then my later life in public policy. And in particular, bringing together these worlds at the intersection of climate science and climate policy. We, of course, are in the midst of the crisis of anthropogenic climate change, which is going to have extraordinary effects on our ways of life all around the world. And much of my role in helping to mitigate that crisis involves investigating the physical processes of what leads to the genesis of extreme weather events. What do I mean by that? Hurricanes, tsunamis, wildfires, you name it. Needless to say, we've been in a year where we've seen a great many of these types of events. Hurricanes Helene and Milton, for instance, in the American South, or even here in New York City, very close to our home, wildfires in parks scattered across the city because the weather's been so dry. We have had a dearth of precipitation for many months now. Understanding these physical processes is one thing, but what I also strive to do is understand how these events affect society, our societal governance, our macroeconomy, and in particular, what are the steps we need to take to mitigate loss of life, loss of property, and economic damages. So my research brings together both of these worlds and seeks to understand that we're not studying these disciplines as silos, because that's simply not how the world works. I'm sure most researchers will tell you it's a very messy and chaotic process. It's a sort of creative destruction, as the economist Joseph Schumpeter would have called it at one point in time. It's a process of constant going down rabbit holes. You come up with one lead, you pursue it, and maybe it bears some fruit. But most times it also leads to even more rabbit holes, more questions to answer. A lot of the research right now, and what I'm trying to help pioneer, is in developing, in particular, using these new tools in artificial intelligence and machine learning, novel ways that we can actually motivate the physics of what causes these storms by way of these statistical techniques. Traditionally speaking, if you were to work at NASA or NOAA and you have access to these really high-tech, just fascinating supercomputers, far more computing power and abilities than what we use at home or work. Generally speaking, these computers are able to simulate physics equations that, for instance, might govern how air flows in the atmosphere or how water flows in the ocean. And these are very complicated equations that are quite difficult to simulate to actually predict weather and climate flows at some point in the future. You can't do this on your home computer. You need a supercomputer to do this stuff. However, with the advent of AI and machine learning, there's been a renaissance of research dedicated to investigating these tools and examining, can we use machine learning to effectively learn the physics of what's going on by way of data? It's a lot of big data that we're talking about. And we need to be able to develop the tools to actually process that data and come to meaningful, insightful, and ultimately correct conclusions about what the weather might look like 1 week from now. Or if there's a hurricane on the way, how fast will it take for it to hit land? Will it intensify rapidly? Meaning, will it start off as a tropical storm, a tropical cyclone, Category 1, and will it grow, accelerate to a Category 4 or 5 before it hits landfall? These are really critical questions that are not solely in the realm of science research. This is life and death. And at the end of the day, how do we ensure that life is preserved? How do we ensure that everything we've built, our ways of life, our families, our children, our friends, our loved ones, are protected in these events? That's really the heart of what this research aspires to do. So when it comes to teaching, it's not our job to help our students memorize a textbook or simply get good grades. Our obligation, not only to our students, but to our society, is to ensure that they go off from this place to whatever it is that they may do later on in life, armed with the critical thinking skills to challenge the novel problems that will befall their generation. We cannot survive as a civilization if the people running it do not have these skills to manage and deal with every risk that a society may face in its time. So although, of course, there's prescribed curriculum we all of us professors have to go through, at the end of the day, it's within the context of what's transpiring in our world. This isn't theory. This is real life. This is someone's livelihood we're talking about. And conveying the gravity of the burden that these students will have once they become our society's leaders. That, I think, is the crux of what both a moral and an intellectual and a public education, an education meant to serve the public, is all about. So certainly within the realm of pure science, I have my ambitions in helping the field elucidate some of the uncertainties right now between storm formation, between cloud formation, and how the effects of anthropogenic climate change are shifting these very complicated dynamics. But I'm not in it just for the edification of scientific knowledge in of itself. At the end of the day, what matters for me is getting this in the hands of policymakers, ensuring that the people with the power to take action, to devise new disaster relief plans, to build new infrastructure that mitigates the effects of extreme weather events, particularly along our coastlines, right? To protect our forests, our agriculture from wildfires, and ensuring that the people have what they need to weather and rebuild after such crises. At the end of the day, science and knowledge for its own sake doesn't mean anything if we don't strive to make it have an impact on bettering the lives of ordinary people across our country and the world. So that's really what I strive to do in my work.